Hi everybody, in this tutorial I'm going to demonstrate to you the different types of enemies you can use in a 2D platformer and how you can control the movement and combat of these enemies. To follow along with this tutorial, I recommend that you download the starter code for this video from GitHub using the link in the description. If you run the starter code, you should see the following window appear. The current game only contains a few platforms and a player sprite. The player sprite already has all of its animations loaded from a sprite sheet, and I've already implemented gravity and collisions between the player and platforms. To move the player, you can use the WASD keys and the J key for attacking. To understand how this all works, let's take a closer look at the code. First, we'll start with the game and level classes. The base game class is what we use for controlling the game window and the event loop. This class contains methods for creating the window, changing the level shown on the window, and quitting the game. Game class inherits this base game class, and all we have implemented in this class right now is our assets directories. We have directories for the images, the maps, and in the future we could add more directories for music or other sound effects. Next we have the base screen class, which basically controls what is shown on our active screen. So in this class we have several sprite groups defined, such as all sprites, platforms, and then we have two other sprite groups that we're going to use in this tutorial, which are the enemies and bullets. Currently nothing's implemented that is using these sprite groups, but I have them defined here when we use them. Then we have the show method, which just controls our game loop by setting the FPS, calling our event loop, and then calling these update and draw methods. These update and draw methods need to be implemented by whichever class inherits this base screen class. Lastly, we have two helper methods for our player health bar and for handling collisions. Next, we have the level class, which creates all the sprites we need for the first level of the game, and in this class we overwrite our draw and update methods to show the sprites that we need for this level, and then we look for collisions between them. This is also where we draw our player's health bar. To create the game window, we have main.py, which acts as the launcher for our game. This inherits the game class, and we create an instance of the level in our start method. Then we set our active screen to be this level. For our game's map, we are using tiled, so to provide the methods for reading the map, we have the tiled map class in map.py. This class contains methods for rendering the data layers on the tiled map and creating a map. You can find this map in the assets directory under the maps folder, and you can see if you open this in tiled, we have several sprite objects set up here. We have an object layer for sprites, and you can find the player, the melee enemies, and the shooter enemies on this layer. The names are important, and it's how we distinguish which ones are the player and which ones are the melee and shooter enemies. For the sprites, let's start from the base sprite class. This class inherits the Pygame sprite class, and we have some methods defined for setting the sprite image, plus a few basic movement methods. Next, we have the animated sprite class, which inherits the base sprite class. This class is responsible for controlling the animations of our sprite, and we have several methods defined for updating our sprite's active image. For more details on this class and the sprite sheet class, you can watch my previous video on implementing sprite sheet animations in Pygame. Next, we have the physics sprite class, which inherits the animated sprite class. We use this to implement our player's physics, and we implement gravity and acceleration inside this class. We use the Pygame's vector tool library to help us achieve this. Now we have the character class, which we use to represent our characters. So characters include players and enemies, and they both share common properties like health, direction, and platform collisions. Now we have the player class, where you can find methods for loading our animations, moving our player, and updating our player's animations. Lastly, we have the platform class, which just inherits from base sprite since it doesn't have any animations or physics. Before we begin writing any code for our enemies, let's first consider the different types of enemies we usually have in 2D platformers. The first type I want to talk about are melee enemies. These are enemies that approach the player and then attack once they are in range. If the enemy collides with the player during their attack, the player receives damage. The next category of enemies are shooter enemies. These are enemies that carry a firearm and shoot a bullet at the player once they are in range. If the bullet collides with the player, they are damaged. We can also add melee attacks in the case where the player moves too close to the enemy. Lastly, we have boss enemies. These are enemies that are much more difficult to defeat than shooter and melee enemies. It's possible for them to have a unique fighting style, and it typically takes a lot more hits for them to be defeated. We're going to have our boss enemy spawn in a separate stage from the shooter and melee enemies. For this video, we're just going to cover melee and shooter enemies, but I'll address the boss enemy in a future tutorial. Now that the introductions are out of the way, let's start creating some enemies. So to start, I'll create a file called enemies.py. And in this file, I just want to create a basic melee enemy first. First, let's create the doc string. We'll need to import base sprite, which is what we're going to use for the time being before we implement physics. And let me import our colors as well. Okay, so we'll create a new class, melee enemy. Have it inherit our base sprite. And then in the constructor, we're going to have one parameter for our position. So in this comment here, I'll mention the parameter is going to be a tuple, which is going to contain an x and y value. The xy spawn position of enemy. And then we'll also have parameter for our sprite groups. And we'll call our superclass constructors, which, if you remember, base sprite only takes groups as a parameter, so we call our superclass passing in groups. And over here, I'm just going to set a random image. So we'll make our player equal to a size of around 30 by 60. And we'll have it be filled with a red color. And then we'll move it to our starting position. And now we just need to spawn this. But before I do that, I'll copy this and create another one called shooter enemy, so that we can just spawn both our enemies. Over here, this will do the exact same thing as what our melee enemy does for the time being. We're just going to spawn a random rectangle in the specified position. So now back in level.py, we can check when we're looping through our map contents, see if we see any objects with the name melee or the name shooter. And if we do, we want to spawn a melee enemy or a shooter enemy, so we'll import those. And then over here, we'll just do melee enemy, pass in our position by using the tiled map object. And then we want our sprite to belong to the all sprites group and the enemies group. Same over here, we want this to belong to enemies and our all sprites. And now if we run our code, we can see that we have 4 enemies spawning in the correct positions that we had in the tile map. Now we have our enemies spawning in the correct position, which is great, but we don't want them to remain static. We want the enemy to move towards the player or shoot if the player is in range. If the player is not present in the enemy's range, we still want the enemies to patrol and move in a defined pattern. So having the enemies move in a defined pattern should be relatively simple. So let's start with implementing this in our melee enemy class. What we're going to do is create a new method called move, where we're going to handle our enemy's motion. And over here now, let's consider how we can implement this. So what we want is for the enemy to move a certain distance and then move back towards their starting position. So let's say the enemy patrols a distance of around 500 meters. We want them to move 500 meters forward and then 500 meters backward to their starting position. So to implement this, we need a variable to keep track of our enemy's starting position. So over here, let's create a variable called start. And we'll set this to be our center X position. So our current X position is going to be stored in start. And then we're going to calculate the distance that the enemy has traveled each time we call move. So set traveled equal to self.rect center X minus self.start. So that calculates the distance that we've traveled between our current X position minus our starting position. Then we want to check if traveled is less than 500. So if we haven't traversed 500 meters yet, we want to keep moving. So let's say I want to keep moving by 2 in the X position and none in the Y position. Okay, so that works great for moving forward. But how about if we want to move backwards? So to do this, we can create another variable called direction, and we can set it equal to the number 1 to represent the forward direction. So if we're moving to the right, self.direction is equal to 1. And if we're moving to the left, self.direction will be equal to -1. So now in our move by, we can multiply by this direction to the value we're moving by. And now we need to specify our direction variable when we're calling move. So we need to check if we have already traveled 500 meters, we want the direction to reset and to go to the opposite of what it is right now. So first we'll set our new starting position, be the current X position, and then we'll check our self.direction. So we'll say if the self.direction is equal to -1, it will be equal to 1. Otherwise, it will be equal to -1. Okay, now we just need to call this move method. So we'll do this in our sprites update method. So over here, we'll call it self.move. And now if we run the game, we should see the enemies moving 500 meters to the right and then 500 meters to the left. You can see our enemies are moving to the left now. But wait, they keep going. They don't stop and go back to the right. So the reason this is happening is because we're only checking the difference between our X position and the start position. And if we're moving to the left, that distance becomes negative. We need to check the absolute value here on our traveled variable. And if we run the code again now, we can see our enemy moves to the right and then moves to the left and then moves back to the right. But there's still one more problem here. See this enemy on the right position over here? It's going past the window and it's going off the platform. We want to limit the enemy's movement so they don't intentionally go off the platforms and they don't go out of the window. To restrict the enemy's motion, let's add some constraints in our update method after calling self.move. In this method, we can first check if the enemy goes outside the window. So let's say the enemy is moving towards the left and the left side of the rectangle goes beyond the left boundary of the window. So in code, we can say if our direction is negative and the left side of our rectangle has an X coordinate that is less than the left side of the window, which is the 0 coordinate, we want to reset the path. So this means that if we're trying to move towards the left boundary of the window, and if we go past it, we're going to reset. Similarly, we're going to add another conditional to this statement. So we'll add an OR, and we'll check if we're moving to the right direction, and the right side of a rectangle goes beyond our window's width. So if window.width.value, and this window is a constant. And if we check this constant, we can see that I have a value width defined here, that it has a value of 1280. So if the right side of a rectangle goes beyond this value of 1280, we're also going to reset the path. I'll add a comment here saying that this is for restricting out of screen movement. Now let's think about the platforms. In this case, we need to check if our enemy is colliding with the platform, and if so, we want to make sure it doesn't accidentally get off the platform. To do this, we need to first add a parameter to our sprite. So over here, I'm going to add a parameter screen, and it's going to be an instance of our base screen class. We'll import base screen. And remember that our screen class contains all our sprite groups, and I want access to our platform sprite group. Over here, I'll create a member variable called platforms and get the platform sprite group from that. Now I need to check to make sure our enemy is colliding with the platform. So to do that, I can use Pygame function. I'll import Pygame. And over here, I'm going to say platform is equal to pygame.sprite collide any. And we're going to check if this enemy is colliding with any of the platforms. So we'll check if platform is not none. We need to restrict our movement then. So let's consider that the enemy is moving towards the left and they're about to approach the left side of the platform. If their left boundary goes beyond the left boundary of the platform, we want to reset their path. And if the right of the enemy's rectangle goes beyond the right boundary of the platform, we also want to reset the path. So over here first, we'll check the right side. So if we're moving in the right direction, and our rectangle's right goes beyond the platform's right, we want to reset the path. We can do it just by copying this. And then for the left case, we can say if we're moving in the left direction and the left side of a rectangle is less than the left side of our platform, we also want to reset the path. Here add a comment, restrict off platform movement. Okay, so if we run the code now, well, we're getting error because we didn't import our green. So over here, when we're creating our melee enemy, I'm going to pass an instance of this level. We're just going to pass in self. Now we can run this again. And you can see now that our enemy movement is restricted. Okay, so to wrap it up, let's do some refactoring first. So over here, you can see this code is being repeated a few times. What I'm going to do is create a new method called resetPath. And this is just going to have these two lines. And I'll add a docstring method for resetting enemy path. And when we need to do that, we'll instead call this method. The last change I want to make is that the distance of 500 is a bit long, and I think it's unnecessary for the enemy movement. So I'm just going to restrict that to 250 instead of 500. Alright, enemy patrolling is now set up, but how can we make the enemy follow the player? There are a few constraints we should consider before writing any code for this. First, the enemy should only move towards the player if the player is on the same floor as the enemy. So for example, if the player is on the second floor and the enemy is on the top floor, the enemy should not be attracted to the player. Second, just because the player is on the same floor as the enemy doesn't mean the enemy should automatically start moving towards the player. We need to define a range so the enemy only sees the player when they're close enough. The best way to show why this is important is to consider if our game had a camera. It doesn't make sense for the enemy to start moving towards the player when they're so far away and not in the camera's view. Lastly, the enemy should still move towards the player if the bottom of the player is visible in the enemy's line of sight. So if the player is jumping and they're still visible to the enemy, they should still move towards the player. The easiest way to implement a detection feature which recognizes all of these constraints is to create a box around each enemy. We can call this our detection box, and if the player is present in this box, the enemy's movement changes. We can set the box so it captures a region above the enemy's feet and slightly above the enemy's height. By doing this, we limit the enemy's detection capability to be within a defined space that also addresses all of our constraints. To implement this box, let's add a detection box member variable to our code. Over here in our constructor, above where we add the platforms, we'll create a new member variable called detection box. And we'll set that to be a Pygame rectangle with x coordinate 0, y coordinate 0, a width of 400, and a height of 110. This will make it so that our detection box is much larger than our enemy sprite, and so we have a large region where we can detect the player. Now we need to create another function called detectTarget. This is our method for handling the detection box. In this method, we want to update the detection box's position. We'll set our detection box center x value be equal to our enemy's center x value. And we'll set the bottom of our detection box to be equal to our enemy's bottom. Then we can call this detectTarget function inside our update method. Now in our level file, in our draw method, we want to draw the detection box, and we're going to do that by checking this if self.game.debug mode conditional. Inside our game class, I have this member variable called debug mode. We need to change this value to be equal to true, and if you do so, this conditional will be triggered. Inside this conditional, we want to check each of our enemy's sprites. So if the enemy contains the detection box field, we want to draw a rectangle around that enemy. We'll take our game surface object, use the color cyan to represent this rectangle, and then we'll specify the rectangle we want to draw, which is the enemy's detection box. And then we'll give that a border radius of 1. Okay, now we can run our game again. And now you can see that our enemies are moving with this detection box as they move right and left across the screen. Now, back in our melee enemy class, we need to change the motion of the enemy when the player is in our detection box. To do this, we need to specify the mode the enemy is in. So at the top of this class, we're going to create an enum class called mode, and we're going to specify 2 modes, a normal mode and a target mode. At the top of this module, I'll just have to import from enum, import enum, and that's the class we inherit for our mode. I'll add a docstring, specify enemy current mode, and then now in our detect target function, we're going to check if our detection box is colliding with the player. So to do this, first we need to get a reference to our player from our screen. So over here, we'll say self.target is equal to screen.player. Then over here in our detect target method, we're going to check if the rectangle is colliding. So if the detection box is colliding with target rectangle, we want to specify the mode to be target. Otherwise, we can reset the mode to normal. Then in our move method, we want to check which mode we're at. So we'll have to define self.mode in our constructor. We'll set that to normal at the beginning. And now inside our move method, I'll check if the mode is equal to normal. We want to do all the steps that we did previously. If the mode is set to target, we want to follow the player. To do this, we first have to check which direction to move the enemy in. We say self.direction equal to 1 if the target's x position is greater than our x position. Otherwise, -1. So we move right if the target is to the right of our enemy, otherwise we move left. And we can do the same thing, self.moveBy, self.direction times 2, and then move 0 in the y. And now we can see if we run this code, we can see that the detection boxes move as normal when the player is not inside the box, but when the player moves inside the box, the enemy follows the player. When the player leaves the detection box, the enemy proceeds to go along its normal route. That concludes the basic code that we have for moving the enemy towards the player. I'm going to refactor this code now into an enemy class that we can use for both melee enemies and shooter enemies. This will help us avoid duplicate code across both classes. Over here, I'll create a new class called enemy. We're going to have this class inherit our characters class. We'll need to import this character class, and then we can inherit it. And our constructor will also call our superclasses constructor. And you can see for our character class, we have a few attributes defined over here that each character shares. So this is something for both players and enemies. We have health, ground count, shoot count, attack count, direction, and a dictionary called properties. The properties dictionary is used to get different sprite attributes like the max speed, max fall speed, and deceleration. Over here, to call the superclass constructor, we'll need to provide arguments for the position, props dictionary, and the sprite groups it belongs to. Over here inside the constructor, we're going to have parameters for position. It's going to be the same as what we had inside our melee enemy. And then we'll have a dictionary for the properties. It's going to take a string and a float. And then another parameter for the sprite groups this sprite belongs to. Okay, now we can copy the mode first. Over here, we'll put our mode. And then we'll copy our reset path and detect target code. Now, since our enemy is using physics sprite class now, because our character inherits physics sprites, we have a position vector, which is basically assigned to the rect mid-bottom of our sprite. So over here now, instead of using self.rect.centerx, we can use self.position.x. Similarly, over here, we can change this to self.position.x. And now we need to set our velocity equal to 0. Now we also need to provide an attribute in this class called self.start. I'm going to set that equal to self.position.x. And we'll also need an attribute for the mode, which we're going to set to normal. Now in our melee enemy, we can take these two variables out. Self.start can be removed, and self.mode can be removed. Another takeaway is that inside our character class, we have an attribute for the direction. Now we don't need to define the direction attribute here either. Now, melee enemies and shooter enemies both have the patrolling functionality, so we're going to copy our move function here too. Over here, I'll copy in the case that the mode is normal. And then we're also going to copy over our update code. So our physics sprite already calls self.move, so our update doesn't need to contain this anymore. We can copy the rest inside our enemy class, since this will be shared between both melee enemies and shooter enemies. And then we can get rid of this update function inside our melee enemies. Both the melee enemy sprite and the shooter enemy sprite will contain a detection box. The detection box size for both sprites will be different because the shooter enemy will fire bullets, so the detection box should be larger in width than it is for the melee enemies. But for this reason, we're going to add another parameter to our enemy class called detection. And this is going to be a Pygame rect object. Now over here, we'll specify that our detection box is going to be equal to DET. And since we copy this update function over here, we need access to our platforms. But to get access to our platforms, we need to get the screen first. And at the top, we're just going to copy what we have in melee enemy. So make these two there. And we don't need a detection box here either. Let's create a dictionary properties right at the top. And we'll make it with the following values. So for the melee enemy, I have a few constants defined here, which basically holds the different properties that we have. Over here, we have attributes for the max speed, the max fall speed, deceleration, acceleration, detection box, melee range, etc. So for our properties, we mostly care about the max speed, the max fall speed, And then in our super class call, pass in position, props, screen, liking rectangle for our detection box. And lastly, the sprite groups that this sprite belongs to. And now I'm going to do the same for the shooter enemy. I'm going to take a few minutes to add some sprite sheet animations and additional setup for our character class, so I'll see you in a bit after making those changes. And I'm back. Let me quickly give you a rundown of all the different changes I made. So for starters, inside our enemy class, I noticed that there were some fields that were still using the rectangular center value, so I changed those to use position X. For our max distance, I'm using the value in the property now instead of using the hard-coded value of 250. Similarly with the movement, I'm changing the acceleration in the X direction now instead of using the move by method. In the update method, I'm calling the superclass's update method so that the enemies spawn in the correct position. Now back in melee enemy, there were a few constants which I didn't use the dot value field. Make sure you do that to avoid any errors. And the big changes in self.load, which basically extracts all of the images from our sprite sheet and creates a few animations. And then inside the anime method, we control these animations. And for the shooter enemy, I took the same things that I did from the melee enemy and just made it for the shooter. So for the properties, I have the values defined from the shooter enemy constants. And for the sprite sheet animations, I'm extracting the shooter enemy's sprite sheet frames now. You can see over here, I'm also controlling the animations, depending on what current active animation is set. For the shooter enemy now, we don't have anything specified in the move method. The reason for this is because when the player enters the detection box of the shooter enemy should instead shoot at the player instead of trying to move closer towards them. If we run the game now, we can see all the changes that have been made. You can see how the enemies are now using their sprite sheet animations and they still follow the player like they did before. There were a few more changes made inside level.py. Since we're using physics sprites now, we have to account for gravity inside our enemies. So we have some code here to make sure that our enemies collide with the platforms and don't fall through the platforms. To do that, we use this handle collision function, which basically checks all sides of the enemy and makes sure that none of the sides go through any of the platforms or any of the other sprites. I hope you enjoyed part 1 of this video series on enemy movement. I didn't get to cover everything I wanted to about enemies in this video, so I'm planning to make a 3-part series that will cover melee and shooter enemy combat as well as a boss enemy stage. Please subscribe to see that video later on in the future and give this video a thumbs up if it helped you. Hopefully I'll have part 2 and part 3 up soon, so feel free to leave a comment if there's anything else you want to see in those videos.